Hello students, today I am going to explain you about sorting. So what is sorting? So sorting is a way of arranging elements in either ascending or descending order. So there are different sorting algorithms available. So the different sorting algorithms are, the problem is sorting, and the different algorithms are selection sort algorithm, insertion sort algorithm, bubble sort algorithm, merge sort algorithm, quick sort algorithm, and heap sort. So these are all the different types of sorting algorithms available. The problem statement is sorting the set of elements in either ascending or descending order. For that problem, we have different algorithms. So selection sort, it is going to it is also going to do sorting. Insertion sort, it is also going to do sorting. Bubble sort, merge sort. So the purpose of all these algorithms is to sort elements in either ascending or descending order. So today we are going to see about two important sorting algorithms. One is selection sort and the one is merge sort. So selection sort, it is a comparison based sorting algorithm. So and merge sort, it uses a technique of divide and conquer. So I am going to explain you today about these two sorting algorithms. So what is selection sort? So how it is different from all other sorting algorithms? So the selection sort, it is a sorting algorithm, and in this sorting algorithm, take an array of elements. So this is an array ARR of 8 elements starting from index 0 to 7. So this is the given array, and the selection sort will work by sorting the first element in the correct place. So selection sort works by fixing the first position with correct value, and next with the second position, and the next with the third position, and finally the last element is going to sort last. The first element is going to sort first, and the last element is going to sort last. So this is the main idea of selection sort. So in selection sort, always first element, the element which is going to fix in the first position is the minimum element. Okay. So this is the main idea of selection sort. So how it will work is by using two pointers I and j. So I is which is pointing to 0th index, and j which is pointing to I plus 1 position. So I, it is pointing to 0, and j, it is pointing to I plus 1 position. Okay. So now compare these two elements. So 2 is less than 5. Yes, 2 is less than 5. It is not greater, it is lesser value compared to 5. So don't do anything, just increment j value. Now compare 2 and 1. Compare 2 and 1. 2 is less than 1? No, it is not less than 1. 1 is lesser value. So our aim is in selection sort, always we want the first element to fix first, and that should be least among all the values. So this 2 is less than 1, this condition is false because 1 is lesser. So just swap these two values. So if 2 is less than 1, if A of I, ARR of I, which is less than ARR of j, then swap. Okay, this is not true. This is not true. It is greater. This is greater than swap. Swap both array of I and array of j. Okay, so the array of I and array of j, you are going to swap it. So this is 2 and this is 1. And again increment j and compare this value and this value. So 1 which is lesser than 10, so no changes. Now 1 which is less than 3, no change. Then increment j, 1 less than 4, no change. 12 less than 1 less than 12, no change. 1 less than 9, no change. Okay. So after that the inner loop gets the inner loop value it is 7. So the j should run up to n. Okay. So 7 is less than 8, condition true. After that j gets incremented, which is 8. Okay, it points to some 8 position, which is 8 less than 8, condition is false. So the execution stops here. Okay. Now we compared this, we actually sorted this first element, the first correct position. Okay, the next, this is already sorted. Okay, now we are going to concentrate on only on this part. This is I and this is j. So always I plus 1th position is j. Okay, so now this is I position, this is 5 and 2. So which one is smaller? This 2 is smaller than 5. Okay, we always want the smallest value in this position, the second position. So 2 is swapped and 2 and 5 is swapped. Okay. Now j gets incremented. Now compare 2 and 10. 2 is lesser. 3 and now j is incremented. 2 and 3. 2 is again lesser. 2 and 4. 2 is lesser value. 2 and 12. 2 is lesser. 2 and 9. 2 is again lesser value. Okay. So it comes out from the loop. Now these two values are in the correct place. Okay. Now this is I and this is j. Okay, compare these two values. 5 is less than 10. So don't touch this. Then increment j, 5 and 3. Compare these two values. 3 is lesser. So if it is lesser, swap it. Then increment j. 3 and compare 3 and 4. 3 is lesser, don't change. 3 and 12, 3 is lesser than 12, no change. 3 and 9, compare these two. 3 is lesser, no change. And j, it comes out from the loop and I gets incremented. So now these three values are correctly in the sorted position. Correctly in its position. Okay. Next. I and j. So these, this is I and this is array of I, array of j. Compare these two values. This is greater than this. So we want the lesser value here. So swap these two values. So 5 it is lesser than 10. Now it, okay, now it is right. Now increment j. Okay, I is here. Compare 5 and 4. Compare to 5. 5 is greater than 4. So swap. Now increment j, compare these two values. 4 is less than 12, no change. 4 and 9, compare these two values, no change. And j comes out from the loop. Now increment I. So these 4 elements get sorted. Now compare I and j, 10 and 5. So 5 is less than 10, so 5 should be here and 10. Swap these two values. And then increment j, 5 and 12, 5 is lesser, so no change. 5 and 9, 5 is lesser, no change. J comes out from the loop and then I. Now compare I and j. So 10 and 12, 10 is lesser and 10 and 9, 9 is the least value, so swap. Other than this element, so swap. And this is the end of our sorting, and the I should start from what is the initial value for I. So we need to fix the initial value for I and the end value for I. So I should start from 0 and it should move up to 6, that is enough. Not not up to n, okay, or n minus 1. So you start I with 0, I should start from 0 and it should reach up to 6, that is enough to compare all the elements. So I should be less than n minus 1. Okay, so I value is 6, 6 is less than. So what is n 1, it is n is total number of element, n is equal to 8. So 8 minus 1, which is 7. 6 is less than 7, condition 2. So I should n, so the maximum limit of I, it is less than n minus 1, and then I plus this. And j should start from, so j should start from I plus 1 and up, it should go up to n minus 1. That is, j should less than n or less than or equal to n minus 1 and then j plus plus. So this is the value we need to set for our loop. Okay. So this is how the selection sort will work, and I am going to implement this as a code now. Okay. So I am going to use only the function or the entire, I am not going to write the entire program. I am going to write only the selection sort function. So selection sort, the selection sort is the function name, and the parameters used here are array. The ARR is the array and total number of elements in the array. Okay. So here we can declare our variables if needed. For swapping, I am going to use this temporary variable. So I starting value, it should start from index 0 and it should reach up to 6. So I should be less than n minus 1 and then I plus plus. And j should start from j should start from I plus 1 position. So if I starts here, j should be here. Then only we can make comparison. So j should start from I plus 1. J should be less than 7. Okay, less than n. J should be less than, that is 7 should be less than 8. This is the condition 2, right? So j should go up to this value. So j is less than n and then j plus plus. Okay. So now do comparison. So compare two elements. If array of I is greater than array of j. Okay, we always want the smaller element in the I position, right? So if, for example, if 2 is here and 1 is here, this is greater, right? 2 is greater than 1, then we need to do swapping, right? So how will you do swapping? Swapping using a temporary variable which is called as temp. So what I am going to do is, for example, 2 is here and 1 is here. So array of 0 is having 2 and array of 1 is having the value 1. So we need to swap using temporary variable. Now temporarily we are going to store this variable here, okay, and then we are going to replace this 1 here, and then we are going to store this value here. So this is how we can implement sorting, okay, implement swapping. So we can perform swapping by using temporary variable. So in temp I am going to store array of I, and then I am going to store array of j value to array of I, and then temp to array of j. So this is where the swapping is happening. So here is the part, the swapping is done. So here we are comparing these two elements, and these 3 lines is used to swap these two elements. Okay. If this condition fails, j gets incremented here. If these two elements are already sorted, then j gets incremented automatically. It goes, go and see the next element to compare with I. Okay. If the condition is true, then it can perform swapping. Okay. So this is the code for sorting. This is the code for selection sort. Okay. Finally, our array, we can return the entire array. So that will be in the sorting order, sorted order. Okay. This is about selection sort, and the running time of this algorithm is, the running time of this program is, this loop takes n time to run this. Okay. And this is the basic operation here. Okay. And this is the basic operation. And this loop is, this will take n minus 1 time to run. So totally it will take n square approximately. It takes approximately n square running time. Okay, n square minus n, which is approximately equal to n square. So the time complexity of this algorithm is big of n square. So this is normally for all comparison based algorithms. Okay, big of n square. Okay. So this is about selection sort, and the next sorting algorithm we are going to see about is merge sort. So the next sorting algorithm we are going to see about merge sort. Merge sort, it uses a technique of divide and conquer. So divide and conquer, it is an algorithmic design technique which is used by merge sort. And for example, take an array, okay, of n is equal to n elements, n is equal to 10. Totally 10 elements in the array. Okay, we are going to implement merge sort here for this array. Okay. So merge sort, it uses divide and conquer technique. Divide and conquer means we are going to divide an array into we are going to divide into equal parts of two array. Okay. So how we can divide this array into two array? By taking a midpoint. So the midpoint of this array is this 5. Okay, 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. Okay, take this as midpoint. So the low, take this as low, and take this as mid, and this is high. So low, which is pointing to index 0, high, which is pointing to n minus 1 position, and mid, it is pointing to low plus high by 2. Okay. So 0 plus 9 by 2, take the floor value, which is 5. So you are going to divide the array. For example, the array is A. You are going to divide the array from low, comma, mid minus 1. This is one array, and another array with low to mid minus 1. Low to mid minus 1 is one array, and mid to high is another array. Okay, we are going to divide the array into two halves based on the mid position. Okay, so now the array will be divided like this: 5, 6, 1, 10, 7. This is one array, and another array 21, 2, 4, 3, and 8 is another array. Again, divide this array into two equal halves. 5, 6, 1 is one array, and 10, 7 is another array. 21, 2, 4 is one array, and 3, 8 is another array. Again divide this into two. 5, 6, 1, 10, 7, 21 to 4. And again divide this into two different arrays. So we are going to divide a problem into equal length subproblems. Okay, that is divide and conquer. So we are going to divide the array into, we divided the array into two equal halves. So these are subproblems. Okay. So if we solve this subproblem, we get the solution for the main problem. So this is about the divide and conquer. So now we divide it. Okay. For example, take these two divisions. Okay, these two partitions. So how, okay. So after this, after dividing this, we are going to merge, sort and merge. Okay. After dividing this, we need to sort and merge. Okay. 5 and 6. So 5 and 6, sort it and merge. Okay. 10, 1 and 10, sort it and merge. These two, 2, 7, sorry. This is 7, 2 and 27, 21, sorry, 2 and 21, sort and then merge. Like this. Okay, after that again, for merging we are going to sort and then merge. So we need to do sorting and then merging. Okay. So here 5, 6, this is 1, 7, 10. Here it is 2, 21, 3, 4, 8. And then we are merging these two. 1, 5, 6, 2, 7, 10, 21, 3, 4, 8. This is another array. And then merge these two. 1, 5, 6, sorry. 1, 2, 5, 6, 7, 10, 21. This is one array. This is another array. 3, 4, 8. So finally we are going to sort and merge these two arrays. That is 1, 2, 3, 4, 5, 6, 7, 8, 10 and 21. So this is the sorted array. So this is how the merge sort will perform. So this is how the merge sort will do sorting. Okay, this is the procedure of merge sort. Divide and conquer. First, the entire array should be divided into equal halves, and then after getting the individual element, during the merging, every element should sort and then merge. So this is the final array. For example, take these two array. Okay, we are going to implement these two array. Okay, so this is one sorted array and this is one sorted array. We are going to merge these two sorted arrays. Okay, so we are going to perform these two merge and sort here. So take this is A array and take this is B array. Okay. So we are going to find, so after implementing the merge sort algorithm, we are going to finally get this sorted array. Okay. So for doing merge sort, use two pointers. For A array there is a pointer which is I, and B array there is a pointer that is J. So this is the array B, okay, and our resultant array which is called as C array. So C array is the resultant array, Here I am going to use a pointer, index pointer, just pointing to the index 0. Okay. So now do comparison. So this is one sorted array, this is another sorted array. We are going to merge these two sorted array and finally we get the final sorted array. So compare array of I and array of I, there is A array of I and B of J. Compare these two elements. If A of I is less than B of J, then copy this element from here to here. Okay. So this is lesser than this. So just move this one here. So whichever is lesser, move the particular element to C array. Okay. So if A of I is less than B of J, then what I am going to do here is I am going to move whatever in A of I to C of K. Okay, this is K index pointer. Okay, so I am going to I shifted this one here to here. Okay, and then increment I and also K. Okay, so increment this I and this K. Okay, so now compare this array of I and B array of J. Okay, A of I and B of J. So this is 2 and this is 3. So again this is having the lesser value. So then copy this 2. Just move this 2 here. Okay. And then increment this I. Now compare 5 and 3. 3 is having lesser value. Okay. So if B of J is having lesser value compared to A of I, then what we need to do here is move this value here to here. Okay, increment this K and then move this 3 to C array. Okay, so after moving, increment this J value and K value. Okay, so we moved B array's value to C array and then increment the I as well as K. Okay. So now compare, okay, this is I and this is J. Again, comparing these two values, 4 is lesser value compared to this 5. So now move this B array's value to C. Okay, that is B of J, that is 4 to C of K. Okay, now increment J and also K. Again compare. So this should iterate. Okay, so this should this should be in the loop, right? So use a loop here to iterate. So this loop should end till, okay, this I should reach until this n value. For example, the size of this array is n, the size of this array is m, then I should be less than n and also j should be less than m. So this is the end condition. Okay, so I should reach till this n and j should reach till the m value. Okay, until this should iterate till n and m. Okay. So now compare 5 and 8. So 5 is the lesser value compared to 8. Now move this 5 from A array to C array. Increment this I and increment K. Now compare 6 and 8. Again 6 is lesser compared to 8. Now move this 6 to A array to C array. Increment I value and increment K value. Okay, increment I by 1 and K by 1. Now compare 7 and 8. Again 7 is the lesser value compared to 8. Increment I value, increment I and also K. Now compare 10 and 8. So 8 which is lesser compared to 10. Okay, so move this 8 here. Now increment J and also K. Okay, so once it gets incremented, okay, now compare, now check this condition. Always after iteration, always it will check for this condition and then it enters into the loop. So I which is 5 which is less than 7. The total number of elements in this array is 7. So it is true condition. And J, what is J value? J, it moved to 10th position. Okay. Or take this as 0, 1, 2. Okay. Take this is A array and B array of starts with the index 0. Okay. 0, 1, 2. So now J is in the index of 3. Okay. The total elements of this B array is 3. So 3 is less than 3, condition is false. So if the condition is false, then move all the elements from this array to this array, because there is no elements to compare with this element, with all these elements. So move the remaining all elements of A array to C array. Okay? Because the J moves to the moves out of bound. So copy all the elements from A array to C array. Okay. So for that we need to write the code again. Okay. This is one code. If I is less than the array length and J is less than the array length. For example, if J is greater than M, what happens if J is greater than M? We need to move all the remaining elements of A array to B array. Right. So if J is greater than M, so we are going to move elements of A of I to C of K. Okay. I plus plus and then K plus plus. If J is greater than M, we are going to move all the elements. Okay. Or we can say I is less than M. If I is less than M, only if this condition is false but J is greater than M is this condition is true, but J less than M is false, that is I less than N is true, then we are going to move this. Okay. The remaining elements from here to here. Okay. While J is less than M. For example, if this is the vice versa case, if this is the vice versa case, then we need to move all the element of J array to K array, B of J to C of K, J plus plus and then K plus plus. So this is the merge sort. Actually, this is how the merge sort will work. This is just like a code snippet. I didn't write the entire function. This is like a code snippet to understand how these two arrays gets merged as a sorted array. Okay, so this is about merge sort. And what is the time complexity of this merge sort algorithm is big O of n log n. Big O of n log n is the time complexity of merge sort. Whereas the time complexity of selection sort is big O of n square. Big O of n log n and big O of n square. So compared to n square, this n log n is having lesser value. Compared to n square, this n log n is better compared to this n square. Because the order of growth of n square is much bigger compared to n log n. So n square is having high time complexity. Okay, so the efficiency of the algorithm is good for this big O of n log n. So merge sort is comparatively selection sort compared to selection sort. Merge sort is best sorting algorithm. So this is about selection sort and merge sort. Hope you can able to understand this lecture. Thank you.